Welcome to the first video for Math 135, Section R.1. Again, so for Section R, Chapter R, we're just working on things that should be considered review for entering this course. If there are items that you haven't fully seen before and you need some extra help, please let me know and I can send you some extra resources on how to succeed in these sections. All right, so again, this is review, or it should be review. We're looking at sets. So what is a set? And sorry, right now my mic isn't working, so I'm working without my headset, so you might be hearing my pen tap a lot. Hopefully I'll get that fixed for the next lecture videos. All right, so again, we are looking at sets. What is a set? Generically, it's a collection of objects. And what are the objects? We would call those the elements or the members. And then set notation is when we use these little braces right there. That would be set notation. Now, for example 1, list the set of months that start with the letter M. All right, let's think about it. So starting our set, let's just list off the months. We have January, that's a J. January, February, March. Okay, March is an M. January, February, March, April, May is the next one. June, July, August, September, October, and November, and December. Okay, none of the rest of them start with an M, so these are the only months that start with M. And this is our set of the months that start with the letter M. Now, example 2, list the set of natural numbers. Okay, what are natural numbers? Natural numbers are, if you think about when a child starts to count, when they're, 3 or 4 years old or older, do they start at 0? No, usually kids are counting out there's 1 cat, 2 cats, or, there's 3 books, and so on. So kids usually start with 1. And then they don't say there's 1.5, 2.5, right, 3. Kids are just counting out the whole numbers. They're not counting out halves or fourths or anything, right? 1, 2, 3, 4, and then we can continue on for how far? Well, infinity, right? So we'll just do those 3 dots to indicate the set goes on, and then we'll do our little braces, and that is the set of natural numbers. All right. So let's look at some more definitions. So the universal set, or the domain, is the set of all elements under consideration. What does that mean? Well, if I go back to the top, the universal set for the months would have been all 12 months, January, February, March, April, May, June, July, and so on until we hit December. That would be the universal set for the months. And then we have something else that's important. It's the empty set, or the null set. And for some students, I know I've had before, you like to write 0 with that little slash through it. Please do not do that. In math class, that would be considered the empty set. I would not consider you're using a 0. So please avoid that unless you're specifically talking about the empty set. Or we can just do the set notation with nothing in it. That's also the empty set. However, be careful. This would not be considered the empty set. Why not, you might ask? Well, it's because this set contains something in it. It contains the empty set, which might not fully make sense, but it's sort of saying we have a set that contains the empty set. So it's not really just the empty set. So avoid being redundant on that and just use one or the other. Now, inclusive would be to include the elements, and then exclusive is to exclude elements. Those make sense with the definition. All right, example 3, list the set of positive numbers less than 0. Let's think about that. On the number line, we have 0, and then we would have 1, 2, so on, -1, -2, and so on this direction. So numbers greater than 0 would be these, and then numbers less than 0 would be these. So we want a number that's positive, but somehow less than 0. Does that make sense? It doesn't. No numbers exist like that, so that would be considered the empty set. There's nothing inside of it. So we could either use the empty braces, or we could answer with empty set. All right, example 4, list the set of letters of the alphabet between A and E inclusive. And then, what about exclusive? So inclusive, again, means to include the elements. So the first one, we're going to include A and E. And then when we exclude it, we're not going to include A and E. So first, let me just list these out for fun. A, B, C, D, E, F, G, and so on. Those are the alphabet letters. What are we trying to look at? We're looking at between A and E inclusive, so we're going to look between A and E and include it. So that set, the inclusive, would be A, B, C, D, and also including E. Now for exclusive, that means we're excluding the boundary points and we're just talking about what's inside of it. And so exclusive would be B, C, and D. All right, so next we're going to look at example 5. What is the universal set in example 1? And I think I may have already mentioned that. So example 1, we're talking about the set of months, right? So the universal set for the set of months would be all of them. So let's go ahead and write that out. I'm going to go ahead and abbreviate. So January, February, March, April, May, June, July, August. What am I missing? September, October, November, and December. And if I'm correct, there should be 12. Let's see. Are there 12 elements in my universal set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Good. Whew, I didn't forget any. Okay, let's see. Next, we have some more notation. We have something that kind of looks like a weird looking E, and that helps you remember. It's talking about an element of. Now, if we slash through that E, it's saying it is not an element of. That not is for slashing through. Next, for finite, it's the number of elements is 0 or a natural number. And then infinite is not finite. So it's the opposite of whatever finite is. So, for example, 6, true or false. So for this first one, it is saying 0 is, what does that symbol mean? An element. So 0 is an element of, and what is this weird capital N? So that is some new notation. N is for the natural numbers, which we went over a little earlier. It's the numbers, counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on, just excluding 0. So is 0 an element of the natural numbers? The answer would be no, so this is false. Next we have Kaneohe is what? So this is saying is not an element of the cities in Alaska. Is that true? Is Kaneohe a city in Alaska? So it's not a city in Alaska, which means this is true, unless somewhere in Alaska they named a city Kaneohe, but not that I know of. So this is a true statement. Kaneohe is not an element of the sets of the cities in Alaska. C, set of natural numbers less than 5 is an infinite set. Okay, let's think. Remember, the natural numbers is 1, 2, 3, 4, 5, 6, 7, and so on. And it wants to talk about less than 5, so not including 5. It's saying that this is an infinite set. And that's not true. It's finite. It is a natural number. And infinite would be not finite. So infinite usually is talking about there is no end to it. But there is, it's finite. We have 4 items. So this would be false. And then lastly, we have n is an infinite set. Well, if I think about that, is there an end to writing out these numbers? Is there the biggest possible number you can think of? Well, you could count up to 1,000,000, and I could say 1,000,000 plus 1. You could say 1,000,001, and I could say 1,000,002. So there is no end to it. So n is indeed an infinite set. So this is true. Now, some more notation. We have this sort of C-like object, I guess, and this is saying a subset, or it means it's included in. So this says that if I do this notation, A, a subset of B, means that all the elements of A are the elements of B. What does that mean? Well, if you were to think, pretend A is a pug, right, like the dog pug, and a pug is the subset of all dogs, right? So we'd have all the collection of possible dogs in the world, right? Golden retrievers, poodles, and so on, and pugs are an element of it. All pugs, right, are dogs. But not all of the dogs are pugs, and that would be a subset. So, to show something not being a subset, when we slash through it, so A is not a subset means some elements of A are not in elements of B. So what you could say is, if I took the subset of cats, cats are not a subset of dogs. So cats would not be a subset of dogs, as a simple example. All right, so let's take a look. Example 7. Let A equal the set of 1 and 3, and B is the set 1, 3, and 5. True or false? So A is not a subset of B. What does that mean? That means that the elements in A are not in B, and that's false. 1 and 3 are inside of this set. Let's take a look at the next one. B is a subset of A. Well, that's not true because not all of B is inside of A. We're missing the 5, so this would also be false. Lastly, B is a subset of B. So are all the elements of B inside B? Yeah, this one's kind of weird, but B is indeed holding the same amount as itself. So this is true. Let's see. Next, we have some more new notation. Do not panic. It's okay. Just take the time. Focus on it. Maybe make some flashcards. Alrighty, so let's see. U, that looks an awful lot like the U used for union. That's an easy way to remember it. U is also known as OR. It's combining all the elements of all sets. Intersection. Think of a staple. You're intersecting the sets, and it's just the common items in all the sets. So if you think of union, like marriage, right? In a union, everything from one person's life and everything from the other person's life become joined together, usually in the concept of union. So you're combining all the sets of your life in a union or a marriage with somebody. Intersection is opposite. Think about having a best friend. You might have 1 or 2 things in common. Maybe you go golfing together, or maybe you have a friend that you go surfing with. It's whatever elements that you have common. Now, the next one is A with a little, looks like an okina, or a little comma hanging out above that little value A. All right, so that means the complement set of A. So it's all the elements in U that are not in the set A. So if I was to think back about my dog analogy earlier, we had the dog and the pug. The complement set of the pugs would be all of the dogs that are not pugs. So all of these ones out here. So the complement set would be the golden retrievers, the poodles, the hounds of different types, the chihuahuas, and so on. That would be the complement set of pugs. All right, so let's take a look at our examples. I believe this is the last example for this section. Indeed it is. Awesome. All right, almost done with the first lecture video of this season. Alrighty. So first we're looking at C complement. What is C? C is the set here. And our universal set, the capital U, is this. So again, for C complement, we're looking at the items in the universal set that we don't have in C. So do we have 1 in C? No, we have 2, 4, 6, 8. We have all the even numbers besides 10. So C complement will be 1, 3, 4, 5, 6, 7, 8, 9, and 10. All the items that are not in C. Now we're looking at A intersect B. So it's only where they intersect, or only what they have in common. The only thing they have in common is a 1. So that'll be their intersection. They only share something in common. Like maybe with one friend you only share badminton in common, or you only share surfing in common. Now we're looking at B, union C. So think of marriage, union. You're taking everything from each person's life and stuffing it together. So B is right here, and C is right here. We're joining them all together. We have 1, 2, 4, 5, 6, 8, and 10. Joining them all together. Now, the next one we have is B intersect C. So only what they have in common. Let's look at B and C. What do B and C have in common? Oh, they have nothing in common. They're not friends at all. Since they have nothing in common, again, you do the empty set, or you could do that for the empty set. Again, this would be incorrect. Do not do that. Next, we have E, the set of elements in A or C. Well, remember, or just stands for union. That's going to be A or C. So we're just going to union up those elements. So whatever's in A and whatever's in B, we'll just combine them together. Let me erase this so I can write that out. Oh, sorry, A and C, not A and B. So it's going to be 1, 2, 3, 4, 6, and 8. Those are the elements in A combined with the elements in C. All right, and then the elements of A and C. What does AND stand for? AND stands for the intersection. So just friends, whatever they have in common. Do A and C share anything in common? They share nothing in common. So because of that, empty set or the other sign for empty set. So they are not friends. All right, so that's a quick run through for these sections, or for the section R.1. Again, this is review. If you need any extra help, please send me an email and I can send you some resources, or we can set up a time to have an office hour. Please let me know.